Hello everyone, welcome to my YouTube channel. In this video, I will be going through ArrayDeque in Java, which is a key topic in data structures and algorithms. So without further ado, we'll dive into this topic. So when we talk about what is an ArrayDeque has been created using an array. So using an array, a deque has been created. So when we talk about the deque is an abstract data type. So using an array, as I told you, this deque has been implemented, and now we will be talking about the features of ArrayDeque. So ArrayDeque is part of a Java collection framework, and it implements deque, which is known as double-ended queue. So double-ended queue means normally from both the ends we can include elements, and it has another feature called insert or remove from both the ends, which I have explained you, and the dynamic resizing can be done, and faster than linked list. ArrayDeque is faster than the linked list. And the final, last but not the least, feature of ArrayDeque is it does not allow null. Looking at why we use an array, simply we have to have a reason for using an concept. So using this ArrayDeque, it is very faster than stack or linked list. And the other reason for using ArrayDeque is it works as a stack and a queue. And the third reason is it has auto resizing. It means we can include as much as elements we want until the memory of the device allows. So it's unbounded, normally known as. So we can include as much as elements we want. And the other reason is that it has efficient double-ended operation using deque. So we can include elements using both the sides. This is what it explains. We will be visualizing the ArrayDeque. So for that we will be going through the operations of ArrayDeque. So as you can see in the number one line, it says that at first 5. So now when we are adding 5, it will be add from the front, not the rear end. And second operation is that at last 50. So from the last, as highlighted, from the rear end, the 50 will be added. And the third operation is remove first. So when we are removing, it will remove first. So the first element from the ArrayDeque we have created is 5. So it removes 5. And again, the last function line has been told that remove last. So when we are removing last, so the last element is the 50, the rear end. So we will be removing the last element of the rear end, 50. So this is all about the visualization part. The terms of the ArrayDeque. So ArrayDeque, we have add and offer. This the first line is about like add function, and the offer will insert elements at the rear end, and the AddFirst, as the name shows, tells itself, it will insert elements from the front and remove all. So these two will be used for removing elements from the front, and remove last, as the name itself depicts, it removes from the rear. And other thing is that peek first and peek last. So peek is used for viewing the elements and not to removing it. And push and pop. Push and pop is another terms we use, but just imagine, push and pop, we know it has been used in the stacks, but since ArrayDeque is one part of the stack, so stack operations can also be implemented here. So because of that, push and pop is there. So it allows stack operations allows ArrayDeque to behave like a stack. And the other thing is that ArrayDeque supports both queue and stack operations. That's why it's called double-ended queue. And unlike other Java collection framework, queues and deque and stack, all three will be working together efficiently in ArrayDeque. Let's implement ArrayDeque on the whiteboard. So without further ado, let's move on to it. It's very easy to understand, so let's understand line by line. when we talk about the first line, it's about import java.util.ArrayDeque. So this is Java collection framework. We have been imported ArrayDeque. So after that, we go on to the second line, public class demo. So I have created a class called demo name, and it has been public access specify has been given, and public static void main string args is these two other code lines which will take us into the Java code. So public class demo and public static void main, these two code lines are the element for the Java programming language, and now we will be creating an ArrayDeque using the string called dq. So from this dq.add, dq.add A, dq.add and dq.add we will be adding 3 elements. So we have to notice this is a queues behavior, and the other main important thing is that using these 3 elements we will be adding elements from the rear end. So is that dq.addFirst and dq.addLast. This is from the word itself. AddFirst and AddLast word itself shows that it's a deque behavior. So now dq.addFirst start and dq.addLast end. So this from AddFirst we will be adding the start element for the first, and dq.addLast. So we will be adding this end element to the last, and now it has System.out.println we have been printing this dq ArrayDeque. So now from this and this all from all 1, 2, 3, 4, 5 code lines, the output I will be now showing to you all. So first of all, dq.add A, it will be adding 1 element, and again dq.add B, so it will be added to here, and dq.add C, this will be added here. So important thing to notice is that why not why can't it come like CBA or something like that? Because as I explained to you earlier, this works as a queues behavior. So it adds from the rear end, so from the right side. So right side means this side, so one by one it will be added. And when we go to this dq.addFirst, so the name says here addFirst, so dq.addFirst in the sense simply, so we have to dq.addFirst start. So this element, start element, we have to add to the first. So we have to do like this. So this start element will be there, and dq.addLast. So we have to use this end element here, and D. So this will be the output of this line, System.out.println, from this stack until here. And now we will be going here. So here it has been said dq.removeFirst and dq.removeLast. We will be removing the elements from now what it says is that dq.removeFirst. From this we have to identify that from the name itself, removeFirst. So we will no more having this first element. So we will be remaining A, B and C and N, but that's another line called dq.removeLast. So because of that, this N will also not be there, and simply ABC. So simply this will be the output of this. For dq.push, when you are here itself, so push and pop, as I explained you in the presentation, this push and pop is the behavior of stack. So since ArrayDeque is part of stack, this behaviors can be also, or these functions can be also implemented. Because of that, this push is there. So dq.push top, we will be going through the output of this. So simply it says that we have to top A, B and C. So newly from this output to this output, as this code requested dq.push top, so this top element will be coming here, and the other ABC, the remaining parts of the elements will be coming here. That's what it is about here. And finally there is something called dq.pop. This is also a static behavior to delete an element. Pushing is something about adding an element. So dq.pop will it says that dq.pop. So dq.pop will remove this element. So finally, when this print statement System.out.println of this deque ArrayDeque dq comes, we will be remaining with and see this will be the final output. So we will no more top here. So this is all about the coding implementation of the ArrayDeque, and these are the 1, 2, 3, 4. These are the 4 outputs. We are explaining about the time complexity. Simply, it's about of 1 is something about when you add or remove elements, there will be no time gone. There will be a constant time. So no matter 10 elements when you add or remove, or no matter 1000 elements when you add or remove, the time will be constant. There will be no time differences. So from the elements, based on the elements, the time will not impact. So we can freely input as much as elements we want. And when we talk about the second one, search of n, so in this part, this time complexity is something different from that. It's opposite. It's like when you implement more, or when you input more elements, the time will also be increased. So this is of n is like that. It works like that. What I will be explaining about the real world applications. Real world applications of ArrayDeque is that when we talk about the browser history in Google or something else in search engine, when we browse, when we look at the browser history, it works as ArrayDeque, and scheduling tasks and training DOM checking and undo or redo operations. These things are based on the ArrayDeques. Now finally, the summary of ArrayDeque is that it combines both queues and stack to create an ArrayDeque, and it's faster than the linked list, important to note. So it's about why we use ArrayDeques, and these data structures and algorithms is basically to measure the efficiency, and based on that we decide what data structure to be implemented to our project. So because of that, it's faster than linked list is an important point to be remembered. And it says that if you ever need to store elements in both directions, ArrayDeque will be a very good choice. Thank you guys, and have a nice day. This is all about the ArrayDeques, and I hope I have been clearly explained the ArrayDeques concepts in data structures and algorithms. Hope you are to see in another exciting data structures and algorithms topic. So until then, goodbye from me.